Hi there, welcome back to the second episode of Laboratory of Irreproducible Results. My name is Mark Dumas and I've been working towards a largish kinetic electronic sculpture. It'll hang on a wall and react to observers in various ways, sort of like a big high-tech mirror. What I did in the last episode was cover the development of this basic building block. It's a 3D printed tile that helps me organize these 16 servo motors and some electronics to provide the basic motion for the sculpture. And what I want to do in this episode is two things. One is figure out, is this thing really ready to be expanded in any meaningful way? And second of all, I want to come up with something a little more interesting than these little levers for the observer to see. So, scalability. I've learned in the past that on really complex projects whose outcomes aren't very certain, it's a good idea to build a smaller version or a portion of the design so that you can evaluate it and chase out problems before you've duplicated them many, many times. Now, when an engineer says, I need to go evaluate a prototype, that's just code words for I'm going to go play in the lab. And that's essentially what I've been doing since the past episode. So what sort of things have I been evaluating in order to ensure that this thing can be scaled up without many problems? First up is physical connection. Since the previous episode, I built up another tile, and now it's pretty easy to verify that these things will snap together okay by just simply doing it. Here's, it's a little difficult to reach in there, but basically they just snap together like that. I've tested all of the various sides and they work pretty well. Now, I would point out that when I was doing the final debug of these snap areas, I was literally making dimension changes in the order of 1/10 of 1 millimeter. And these tiles take 16 hours to print. So rather than wait for a 16-hour print to finish to see if one of these small design changes worked or not, I simplified the work design down to a much simpler part, these little tiles right here, and I just distilled down the tab and socket piece of what I was working on and made the rest of the product design very small so that it was very easy to print these things. I think it took maybe 10-15 minutes or so to print a tile, and so I was able to knock out about half a dozen different design revisions to ensure that these little plugs and sockets worked really well and snug before then copying those features back into the larger design. Now the result is a really nice firm fit that holds the servos in alignment across these tile boundaries, and there's not a lot of wobble either way. It seems like this is going to work really well for holding 2 tiles together, 4 tiles together, or even more. Now at some point I'm going to get to a scale that this thing is so large that trying to suspend the sculpture from these tabs may be more weight than they can bear, but I think that at that point I'll be mounting the whole thing into some sort of a frame. But this works really well for holding the servos into an alignment across these tile boundaries. Okay, next up are the electrical connections between the controller, this Arduino that I'm using here, and the servo controller cards on these tiles. Now, as I add another tile, it would be a problem if I were to have to wire each new tile to the Arduino because I would run out of pins really quickly. But what Adafruit has done is provide another set of pins on the opposite side of the servo controller card here, electrically equivalent to the ones that I've been hooking the Arduino up to, and all I have to do is jumper these connections over to the next the card on the next tile. Now I'm using a 6-wire jumper, but really only 4 of those are being used. The power, ground, and the I2C bus wires. So that really makes it easy to expand this thing. I can snap on another tile, and all I have to do is plug in one of these jumpers to get the logic and the control unit working with the new tile. And if you read the documentation on these things, on the servo cards, you quickly learn that they can you can address up to 62 of these cards on a single I2C bus. Now that seems like a lot, and I think it is. Just thinking through this for a moment, if I were to arrange a bunch of these tiles into a big rectangle, a much bigger sculpture, what does this mean? Well, just for argument's sake, let's assume I'm going to build a 56 tile sculpture. That's each one of these little boxes is one of these tiles. So that means, if I had one sculpture that was 8 tiles wide by 7 tiles deep, that's 56 tiles, and that is, well under the 62 servo tile limit from the I2C bus. And this would result in a sculpture that's about a meter wide and almost a meter deep. So that seems pretty generous to me, and I think that's it's going to fit the bill pretty well. So another aspect of using this I2C bus for controlling all these elements has to do with the speed of the bus and the Arduino, for that matter. Can it move enough servo position information to the sculpture to do interesting things? Now, it turns out with this small a setup, if I just wanted to move all the servos at once, it almost looks instantaneous. But what happens if I wanted to scale it up? Again, let's go back to the example here of 8 tiles wide by 7 tiles deep. That's 56 tiles, and there's 16 servos on each of these tiles, so that's 896 servos. So one thing I'm a little concerned about is how long does it take to refresh every one of the servos on a sculpture of that size? Well, fortunately, I don't have to build it to find out. I can just use this little setup here, and I'll just paraphrase what I did, but I wrote a Arduino sketch that simulates what it would take to drive all 896 servos in a refresh from the diagram I just showed you. And so what the sketch does is turn this servo, and then it sends commands to turn all these other servos over and over and over again, 894 times, and then it comes back and turns this servo is the 896th servo, and it just kind of keeps doing that loop. So visually what I see is, I see this servo turn, and then half a second later, after it's updated all of the other servos, I see this servo turn. And by instrumenting the code and measuring the time within the program, I've learned that, it's right at half a second to send out all of the commands required to update every one of these servos. So that's a little more than, that's going to be a very noticeable delay, which might not be a bad effect, but it does have me thinking about several things. First of all, the I2C bus standard does allow for faster signaling speeds, and I know these servo control cards can be configured to go faster, but I'm not sure yet about the Arduino. That would only speed things up if it were a if the Arduino is not the limiting factor. So another thought that I had is that I may need to come up with some interactive code that only updates the servos whose pixels have actually changed. In other words, I may not need to refresh every servo all the time, for every frame update. So it's another great example of using a small portion of the bigger design to test my assumptions about scale. At this point, I have time to think about how to do that updating. The last area on scalability I want to think through has to do with power distribution to the servos. I mentioned earlier that the power to the servo motors comes in through these kind of a different path, through these little green PCB mounted screw blocks. And I have a confession to make: I really don't like these things. They work well if you're using solid conductor wire, but I'm using this braided wire, and what happens when you try to poke that stranded wire into the opening for these green PCB mounted blocks, it just mushes up the individual wires and you never really get a good connection. These DuPont pins rated for 3 amps continuous. I think 3 amps max is what I'm going to see. Most of the time it's going to be much less current going to the servos. So I'm going to swap out these screw blocks with the DuPont connector, and I'm going to continue watching voltage drops as I grow the sculpture, but I think we're going to be fine there. So overall on scalability, I'm giving kind of a good provisional thumbs up on the scalability of these tiles. The physical snapping together works really good. I know how the I2C bus addresses servos across multiple tiles, and I understand on paper at least how that can be extended to many hundreds of servos. Distribution of 5 volts to the logic portion of the servos look good, or of the servo boards rather, and the distribution of power looks pretty straightforward. I do kind of need to watch that. I would say the only yellow flag that I need to really be thinking about is the performance. When I start getting to hundreds of servos, do I need to come up with some fancy algorithm so that the display updates as quickly as I would like? We've spent a lot of time looking and working on the back side of this tile, but that's not the side that people are going to see. So let's turn it over and start thinking about something interesting to look at from the front side, something other than these little servo tiles that came with each servo. There's a lot of different things I could have used, and we'll probably experiment over time with them, but I've decided my first sculpture on this thing is going to use bicycle chain. So bicycle chain is, you know, it's kind of one of the few things that's durable that comes off of a bicycle on a regular basis, so I'm always looking for ways to recycle it. And if you play with it long enough, you end up arriving at this pentagon, which is about the right size for our towel. So I kind of like that. Now, let's think about lighting here. You'll notice that at some angles, the chain is throwing back quite a bit of light, and other angles it's dark. And so what I don't want to just mount the chain on the servo shaft like this and have it spin flat. I want it to, at some angles of rotation, have this thing pitched out so that it's reflecting light back to the observer very brightly, and then at other angles that it's kind of dark. So you can kind of dial in how bright that particular pixel is. All right, so what we need is some sort of clip that does several things. One is to hold the chain into place like that, so it needs some fingers. It's got to hold it at an angle, and it's got to mount it to the shaft of the servo. So once again, a little bit of 3D printing to the rescue, a little bit of struggling. I've gotten pretty good at this. I can snap on that chain, holds it in place very nicely, pushing it in from all sides, holding it at a nice 45-degree angle, and it does slip on very nicely to the shaft. Get the right angle here. And it's very firm because of the spline shaft of the servo motor. You can actually, you know, spin it. It doesn't slip at all. But there is this one problem where they do fall off with just a little bit of pressure like that. So you can see we don't have a lot to work with here on this servo shaft. It's only about 3 millimeters high and a few millimeters wide. And one thing that comes in the package with the servo are these little tiny screws, which are intended to screw right down the middle of the shaft and hold on either these servo horns or whatever it is you want to control. So at this point, I have relegated myself to screwing these chain links into place. And I'm a little disappointed at that because as you've heard me say and whine about before, I'm trying to avoid using any fasteners, any little screws, and here's now a case where I'm going to have to use 16 of these darn things to screw on the clip and then clip the chain into the clip afterwards. So it's going to get a little more a little bit more time intensive to build one of these things than I really wanted. So, but right now it's the only thing I can think of that will make this semi-permanent. I've given some thought to using some sort of an adhesive to hold this on, but keep in mind I'm going to have to be able to replace these servos from time to time. So if you've got any sort of suggestions, I'm open to them in the comments. Now on the front we have a full complement of these chain links reflecting light, and let's see how well this works. So I'll plug in the Arduino. The first thing that'll happen is they'll go to their center position and then they'll do the wave, just like we did on one tile in the previous episode. Now I've got the light here shining from above kind of in the direction of my finger there, and you can see that when the chains are tilted up like that, they're catching a lot of light, and when they're down like that, they're kind of dark, and then kind of grayscale in between. So can start to see the effect I'm looking for. I think after about 10 of those waves, it goes into a random mode. So, what's next? I think we've got a good building block. There's a few things we've learned that need to watch going forward as we start building more and more of these things. But I think what I really need to cover in the next episode is getting to some level of interactivity. I'm getting a little tired of programming interesting patterns for these things to take, and I'd like to get to a design where I can just have it move based on some hand waving or changes in light or something like that. So I've got several ideas for how to do that, and in the next episode we'll cover one or more of those. In the meantime, I'd like to hear from you in the comments, especially if you've got any suggestions on things to do differently or any questions you might have. Just fill out a comment and I'll get back with you as soon as I can. And until next time, keep on making.